Good morning. Today our topic is capacitance of a parallel plate capacitor with conducting slab. Yesterday it was dielectric slab, but today it is conducting slab between the plates. You have to write the notes, okay, and you send me in my number. Now consider a parallel plate capacitor. This is the parallel plate capacitor. Consider a parallel plate capacitor with area of cross section A. Okay, this is plate A and plate B. Okay, and the area of cross section of the plate is A. Area A. This area is A. Okay, here also same, because these two plates are same. Here also area is A, and the distance between the two plates is D. So this is the distance between the two plates. Or we can represent like this also. So this is plate A and B. This distance is D. So in this case, when initially there is nothing, only air or vacuum. So in this case, the capacitance of the parallel plate capacitor is given by C is equal to E naught A by D. Okay, I will write C naught. Okay, C naught. This is the capacitance of the parallel plate capacitance with air between the plates, with air or vacuum. Same. Now what we have to do, we have to insert a conducting slab between the plates. So between this plate A and B, we have to insert some conducting slab. Let's say this is the conducting slab. The thickness of this conducting slab is T. Or this is the conducting slab. The thickness of conducting slab is T. Okay, this is plate of capacitor. These two are plate of capacitor, and area of plate is A, and this is conducting slab. Conducting slab means it conduct current, or it's a conductor only. So we have studied it. When you keep a conductor, suppose this is a conductor inside an electric field, so this is electric field, and when you place conductor in electric field, inside this conductor, electric field is 0. So similarly, due to these two plates, the plates are opposite in charge. One side is plate A is positive and plate B is negative. So due to this charge, there will be some electric field from positive to negative. Let this electric field is E naught. So we have placed a conducting slab inside this electric field. So inside this slab the electric field will be 0, right? Similar to this one. Since the electric field inside the conducting slab is 0, but it is not 0 over this region, here and here. Thus, out of the total separation D, out of the total separation D, out of the total separation D between the two plates, this plate and this one, between the two plates, the electric field exists only over the distance, only over this distance, that is D minus T. So over this distance only the electric field exists. So as a result, the potential difference between the plate will be reduced by, so V equal to, so potential over this distance D will be, we know that E equal to V by distance, distance. So potential over this distance means this empty space, in this empty space, so the total potential will be potential over empty space plus potential inside the conducting slab, so potential over the space, this D minus T will be E equal to, okay, over this space electric field is E naught, so E naught equal to V by distance. So E naught into V, distance is D minus T, D minus T. So we will have V equal to E naught into D minus T. So this is the potential over the space D minus T. So E naught D minus T. Now potential over the conducting slab. So conducting slab means the thickness of the conducting slab is T. That means potential over T. So inside the conducting slab E is 0. So according to definition of electric field and potential, E equal to V by distance. Here distance is T, T, and electric field is 0. So 0 into T is 0. So V equal to 0. So plus 0. So we will have only V equal to E naught D minus T. Again, since these two are just like in two infinite plane sheet of charge, right? Two infinite plane sheet of charge, so the electric field between this plate A and B will be, as we have already studied, so that is E naught, E naught equal to sigma by E naught, and again sigma is charge density, which is equal to charge by area, means surface area. So E naught equal to sigma means Q by E naught A. Na? Now V equal to V is E naught. So E naught is this one, Q by E naught A. So this one over into D minus T. D minus T. So this is the potential. Now what is capacitance? Capacitance is Q by V. Na? So Q is Q, V is this one, V is Q by E naught A D minus T. So this Q and this Q will cancel, and this E naught A will go up, E naught A by D minus T. So this is the capacitance. Again I can write this E naught A by D. Okay, if I take common D, D means 1 minus T by D. Nah? See, D into 1 is D. Nah? Minus D into T by D is D and D will cancel, we will get T, right? Nah? So C equal to E naught A by D into 1 minus T by D. So what is this E naught A by D? E naught A by D is C naught. Nah? So we can write C equal to C naught divided by 1 minus T by D. If the conducting slab, again if the conducting slab fully cover the entire space between plate A and B, then we will have T equal to D, right? So in that case C equal to C naught 1 minus, so in place of T I can write D, so D by D. Nah? So C naught by 1 minus D by D is 1. Nah? So 1 minus 1 is 0. So which is anything divided by 0 is infinity.